let's move further. Next question. The potential energy of a conservative force field is U is equal to A times x squared minus B times x, where A comma B are the positive constants. Find the equilibrium positions and discuss same. So when we say so when we say discuss about the same, we have to classify the equilibrium as stable, unstable, or the neutral. Okay, so we'll start with the field, right? First, you find the F. How to find F? F is equal to minus of du by dx. So that is equal to negative d by dx of the u, which is ax square minus b into x. So the differentiation gives minus ax square has 2ax minus bx has a differentiation b. So the result is b minus 2ax. Right. So this is the f. Why we are finding x? Because we need to find out the point x where f is 0, because equilibrium means no net force, right? So at equilibrium the force is 0, right? So force is 0 means I can write b minus 2ax equal to 0, right? So 2ax is equal to b. That implies x is equal to b by 2a. So at this particular position, we can see that the given system is at equilibrium. So this is the point at which the equilibrium exists. Now, in order to identify what type of equilibrium it is, I have to find the double derivative of u. Okay, so let's start with the u once again. So u is equal to ax square minus bx. So first you find out du by dx. Du by dx is 2ax minus b. And I will calculate the double differentiation. So d square u by dx square is equal to, differentiate the above term. So 2ax, when differentiated, we get 2a minus b, differentiation is 0. So this is 2a. They already have mentioned that a is positive. So this means 2a is positive. Right. When this is positive, right, you can say that the u is minimum, because this is d square u by d square is positive, means the u is minimum. This is minimum. So when u is minimum, what type of equilibrium it is? It is called as the stable. it is said to be the stable equilibrium. So first we need to find the position by calculating minus du by dx equal to 0. And then we can perform du by dx equal to 0, d square u by dx square. We calculate that and if identify whether it is positive or negative. If it is positive, it is stable, otherwise it is unstable. Right? Okay. If at all it becomes constant, then that means it is the third type of equilibrium. Okay. So repeat the same problem for this u. U is equal to x cube by 3 minus 4x plus 6. So here we start with the calculation of f. F is equal to negative of du by dx. So that is negative d by dx of the given equation, that is x cube by 3 minus 4x plus 6. So this means derivative of x cube, minus is outside, x cube differentiation is 3 times x square divided by 3. So the 3 will cancel. Okay, minus 4 and 4x minus 4x becomes minus 4. 6 is a constant, so that is going to be 0. So the answer is equal to minus du by dx, that is equal to minus x square plus 4. Force is in this particular direction. Okay, force is equal to this much. Now at the give, if at all I want to find the position where the equilibrium exists, then at equilibrium. At equilibrium, the force should be equal to 0. That means minus of x square plus 4 equals to 0. So minus x square is equal to minus 4. This cancels. So see, x is equal to plus or minus 2 is the answer. So equilibrium exists at x equal to 2 and at x equal to minus 2. So now I need to find out what type of equilibrium it is when at x equal to 2 and when x equal to minus 2. So we start with u once again. U is equal to, this is x cube by 3 minus 4x plus 6. So first you find du by dx, that's already we have the answer, that is 3x square divided by 3 minus 4. So 3 cancels, this is x square minus 4. Then d square u by dx square should be equal to differentiation of x square minus 4. X square differentiation is 2x, right? Minus 4, which means the minus 4 will vanish, it will become 0. So 2x is the answer. So I have two positions now at x equal to plus 2, right? I have to calculate d square u by dx square with x is equal to 2, right? That is 2 into 2, that is equal to 4. I just need positive or negative, right? I don't have to worry about, right, what type of, what is the exact value it is. So at this is equal to 4, right? At 4, this is the positive value. Positive value means the force is minimum, right? This means F is minimum. So if F is minimum, what type of equilibrium it is? That is a stable. Not F, sorry. D is minimum. U is minimum. Mistake. Force is always 0. The U is minimum here. Then calculate at x equal to minus 2, the d square u by dx square at x equal to minus 2 is equal to 2 into minus 2. So that is equal to minus 4. When this d square u by dx square is negative, this means u is maximum, right? So that means it is unstable. This is called as the unstable equilibrium at this particular point. All right, let's move ahead. Next question. Okay, u is given by minus 20 plus x minus 2 the whole square. The question still remains same. Find the position where the equilibrium exists and what type of equilibrium it is. So the answer, x becomes equal to 2 and this is stable equilibrium. Okay, we'll move on to the next topic. It is called as power of a force. Normally, power of a force is defined as the rate of work done by a force. So, power of a force is a measure of the rate of the work done by a given force. Now, because of this definition, it's very clear that there has to be two types of force, two types of the powers. One is the instantaneous. At a given point of time, what is the amount of power that uh, the force is capable of doing work, right? So that's what is the instantaneous power. Second one is called as the average power, right? The force is being applied for a long duration, and because of that, there is a specific amount of work being done. So when it is longer duration, it has to be the average. Okay, so let us move further, right? So there are two types. The type number one is called as an instantaneous power. We denote this as PI for instantaneous power. Okay, so the instantaneous power is nothing but the rate of doing work done by a force at a given instant. Right? So this is measured at an instant of time. At a given instant of time, what is the power? So this is how you measure. So this particular power, Pi, is equal to rate of doing work, dW by dt. But the work is nothing but force into dr. This is dot product, F dot dr divided by dt. Right. So here the R represents the displacement. Right? So F dot dr divided by dt. So we'll try to modify this further. I'll try to take this as F dot. This is dr by dt. Let me club this. It's fine because as far as you are keeping the dot product there, right, it is valid. But what is dr by dt? Dr means rate of change of displacement, right? Displacement by time. Numerator is a displacement, denominator is time. So displacement by time is a velocity. So we can write this as F dot V, right? So here V is equal to dr by dt, denoting the velocity. So velocity is also a vector. That's why I try to represent the vector notation over there. But anyway, I know that the dot products can be represented by using F into V into cos theta. Fv cos theta. This is a magnitude. F represents the magnitude of the force. V represents the magnitude of the velocity. Cos theta is the cosine of the angle between the two. So instantaneous power can be calculated by using this equation. Okay, then going further, we have another type of power that is called as the average power. Now, this is calculated as the total work done divided by the total time taken to do that work. So here we try to take the ratio of the total work done to the total time taken. We'll denote this as P average, which is equal to W total divided by T total. All right. So based on this also we can get some problems. So problem number one. A ball of mass 1.75 kg is dropped from a tower. Find the power of the gravitational force at t is equal to 1.9 seconds. We can take g is equal to 10. Right. So first thing is that I have to consider force into velocity ultimately, right? So we know that what is the direction of the force? Gravitational force is downwards. This is the direction of the force. What is the direction with which the object is falling? That is also downwards, V. Now the angle between F and V is equal to, so that theta can be represented as 0 degrees. Just to identify that, I wrote this. Now, first let us try to find out the velocity. So velocity at 2 seconds is g into t. Okay, so g is 10, time is given as 1.9 seconds, right? 1.9 into 10, it's 19 meter per second. Now I need to calculate the force. Gravitational force F is equal to mass into the gravity, m into g. M is given as 1.75 into g is 10. So this is 17.5 newtons. All right. Now what I need the power. So power is equal to F V cos theta. So F is equal to 17.5 into velocity is 19 into cos 0 is 1. Okay, so this is equal to 332.5 energy. Sorry, it's a power, so measured in watts. Okay, one more question. a particle of mass m is lying on smooth horizontal table. A constant force, that is capital F, tangential to the surface is applied on it. Calculate part A of the question. Average power at t is equal to 0 to t is equal to t. Right. Part B of the question. The instantaneous power. Okay, we start with the equation to calculate the average power. So this is part A answer. P average is equal to total work done, WT divided by total time. Okay, we'll write a small t here. This is actually the total time. I can write T total. Right, so the work done is nothing but, anyway, I can understand from the given problem that there is a mass m. You apply a force, it's going to travel with the velocity v and some acceleration a. Right. So work done is nothing but half into mv square, because it is kinetic energy. There is energy in the particular body, right? That is because of the movement. So half mv square divided by, I'll write a t here. But I cannot write a v here because v is not given. I have what I have, I know only what is the force, what is the mass, and what is the time. I have to write velocity in terms of these values. So let's try to write this. That is half into m into velocity. How do you write velocity? Velocity is acceleration into time. Acceleration is force by mass, f by m, because f is equal to m into a, right? Into, if you want this to be velocity, there has to be a time. Acceleration into time whole square divided by t. Okay, so let us try to simplify. This is half into m f square t square by m square whole divided by t. So m and this cancels. One of t will cancel. No, t in the denominator. So one of the t will cancel. So the average power is equal to f square into one of the t there. Then we have 2 in the denominator into m is the required answer. This answer is there. Okay, so average power is equal to this. Now let's move further. We want to calculate the instantaneous power. So Pi is equal to force into velocity, F dot V, that is Fv cos theta. Since the object is traveling in the same direction as the F, so there is no question of theta coming into picture. It's theta is 0, so cos 0. It's simply F into V. F as it is. V is nothing but, just now we calculated, that is into F square T by, it's V, right? Sorry, it's just Ft by M, my mistake. Velocity is Ft by M. So the answer, instantaneous power is F square into T divided by M. That is the instantaneous power. This is the average power. So we got both of them.